Okay, class, today we're going to start a new unit on quadratic functions. Up to this point, y'all have mostly done linear functions this year, where y equals mx plus b, where your highest exponent of x is 1. Those are linear functions. Quadratic functions, your highest exponent of x is 2. And y equals x squared, remember that's our parent function, our parent quadratic function. In quadratics, the parent function, or like a U-shape, or it's called a parabola. And this is our parent quadratic function, y equals x squared. And they're either going to open up or open down. And so let's talk about the standard form of a quadratic. Okay, your standard form, your function f of x or y equals ax squared plus bx plus c, where a, b, and c are integers, and this a value, this number in front of x squared, if a is positive, if a is greater than 0, then that tells me that the quadratic is going to open up. So it'll be opening up. If a is negative, a is less than 0, it's going to open down. Okay. And so let's look at an example. F of x equals 2x squared minus 3x plus 8. Alright, so the first thing I want to identify is a, b, and c. So a is 2, b is negative 3, c is 8. And then we want to determine, does it open up or down? And this is, a is positive 2, so this is going to open up. Alright, the second thing I want to find is my axis of symmetry. Okay. My axis of symmetry. This is the line that cuts your parabola in half. It makes it symmetrical. So it's going to go right down the middle. Well, this is a vertical line, and so vertical lines are x equals a number. And my axis of symmetry on the quadratic is always x equals negative b divided by 2 times a. And so let's find our axis of symmetry for this quadratic. 2x squared minus 3x plus 8. So my axis of symmetry is going to be x equals negative b. B is negative 3, so plug in that, over 2 times a. A is 2. Alright, simplify this. X equals negative times negative 3 is positive 3. Over 2 times 2 is 4. Okay, so my axis of symmetry for this quadratic will be the first thing that I graph. And so let's put a graph up here. Okay. So we are going to just do a dashed vertical line going right down the middle of my quadratic. Positive 3/4, that's 0.75, so almost to 1, not quite. So let's do this about right here. Let's change colors. I won't do that. Okay. Okay, here's my axis of symmetry. This is cutting my parabola right in half. We know it's going to open up, and we know our axis of symmetry. Okay, let's next find our y-intercept. Our y-intercept. So 3. Y-intercept. Where does my parabola cross the y-axis? And the parabola always crosses the y-axis at C. Whatever your C value is, that is where your parabola crosses the y-axis. And so we're going to put a point at 8, positive 8, right here. Okay? Anytime you put a point to the left or the right of your axis, you want to mirror that point to the other side. And so here's my axis. I want to mirror that point that I just put on the left side of it, put another point on the right side of it, and I want to go exactly as far away from that axis as the left point. So it's 0.75 away from my axis, so I want to go to the right 0.75 or 3/4. And it's going to be right here in the middle of 1 and 2. Okay. So my y-intercept is 8. And then we mirrored that point. All right. Now we want to find the vertex. The vertex. That is it's either your minimum or maximum point. And since this parabola opens up, we're going to have, since this parabola opens up like this, we're going to have a minimum point at the very bottom of it. And it's always on that axis. Wherever that axis is, your vertex will be right on it. And since we're opening up, it's going to be our minimum point. And so what we've got to do is go back to our original function, and we're going to plug in our x value, which is our axis of symmetry, 3/4. So 2x squared minus 3x plus 8. So we're going to find f of 3/4. That's my x value. And I'm going to plug it in our original function and figure out what our output is. Okay, so use a parentheses when you plug in, and we can use a decimal. If you want to use a decimal instead of a fraction, you can. 3/4, 3 divided by 4 is 0.75. Alright, let's use our order of operations, and we are going to square 0.75 first. So I get 0.75 times 0.75. I get 0.5625. Now I'll multiply -3 times 0.75. That's -2.25. Now let's multiply 2 times 0.5625. It gives me 1.125 minus 2.25 plus 8. Okay, so I get f of 0.75 equals 6.8. Just round to the nearest hundredth. Okay, and so that is my output. My input is 0.75. My output is 6.88. And so my vertex, which is the minimum point on my quadratic, is the coordinate 0.75, comma 6.88. So let's go back and graph that as close as we can. 0.75, 6.88. 0.75. So we're on our axis, and we want to go up to 6.88. So 1, 2, 3, 4, 5, 6, almost to 7, right here. That is my minimum point, and now let's just connect our dots. And it's a U shape. There's your quadratic.